going with our next presentation, titles of which is New Glass Screen System with Slender Tempered Glass Stiffeners. And I was talking to Shoji earlier on, and about what it is, and he was explaining to me that it is about his research on their new glass system. He works for Total. He was very kindly explaining to me that he's more of an international salesperson. That's his title, so he's not particularly technical, but he also comes across really, really modest. So if we can please give him a round of applause. And
Thank you.
I'm sure you'll do great, Shoji. Okay?
Thank you very much. Thank you.
Thank you.
I will do my best. Okay, so first of all, I'd like to introduce myself. My name is Shoji Maebashi from Japan, and Japan to here is quite far. It took 18 hours, and and this is where we are from. So first of all, I'd like to introduce our company philosophy. That's we do not. Sorry, it's not the long one. Company philosophy is enable impossible facade construction work with a unique technology and know-how, while always conscious of understanding and pursuing this corporate philosophy. We strive to put customer satisfaction first. This is our president's words. This is one of our flagship architects that we have done. So we did actually all the glasses in this building, and this is one of the famous tourist attraction in Japan. So if you visit, please visit this building too. And as I explained, we are importing glass from overseas because Japan cannot do that much. So here are the countries that we are importing from. So here's Japan, and we are importing glasses from China, South Korea, Taiwan, Philippines, Vietnam, Malaysia, Singapore, Thailand, UAE, and last year we have expanded our business to Turkey with a strong and very trustable partner. And these are the projects that we have done. And as you can see, we mostly do a bigger facade only, something like normal company cannot do. Okay, so let's talk about the glasses. So in recent years, glass are used for external surfaces in order to realize light, liberating, and highly transparent spaces. And these four are the keys for the glass architectures: flatness, less deflection, continuity, and transparency. And today's glass screens construction consists of support frame, tempered glass, and vertical edges of glass and support frame, as you can see in the graph, in the picture. But these highly transparent exterior glass screen constructions are often supported by upper frame and lower frame. Sorry, this is the... Yes. And the... Okay, but these highly transparent exterior glass screen constructions are often supported by upper and lower frame members with three vertical edges. Besides, large scale of glass are tended to be used at this time where the height of the glass screen is same or the higher above the floor level. And there are two types of glass that are used in glass screen construction, and tempered and annealed glass, with differential time allowable stress and the average fluctuating stress for tempered glass. Because of this, tempered glass are often used for glass screen because of strength reasons. However, as tempered glass are made of raw sheet glass and needs to be processed from the same material as annealed glass, so the relation of components between deformation and stress are the same, and so are the deformation limits. But tempered glass are stronger enough to reach the limits of deformation specification, so before it breaks. So in order to utilize the high strength of tempered glass, it is necessary to limit the deformation even if the generated stress is high. Okay. With such conditions, a new glass supports construction method, which involves attaching slender glass stiffeners to the vertical edges of the glass, makes uses the high allowable stress of tempered glass, improves cross-sectional performance and reduces deformations. And this shape allows for increasing bending rigidity. Plus, since this is a method of supporting glass by frame material above and below the face glass, so it is possible to avoid stress concentration at the top and the bottom and edges of the slender glass stiffeners. In addition, prospective dimensions of the lipped glass can be smaller than the conventional glass screen construction method, which has advantage of making the exterior surface flatter and allowing the use of more interior space. So one of my friends is coming to the stage. Okay, so this is called GETA, a traditional footwear that has been remaining over 2,000 years. And as you could see, this also has two teeth to increase stiffeners, like this. Okay, in the case of conventional glass screen construction, the glass ribs bonded to the face glass serve to support the edge of the face glass. On the other hand, in the case of the GETA glass system, which is called GGS, the slender glass stiffeners are sharp shaped as an integral part of the face glass. The shape allows for increased bending rigidity. Okay, as we compare the GETA glass system with other edge-supported methods, the four-sided support construction method is less continuity and transparency, although deformation is reduced. Let's say two-side supports. Well, this construction method provides continuity and transparency, but increases the amount of deformation. So it's not that smart too. And conventional ribbed glass construction, it helps to reduce deformation more than the two-side supports, but it is lacking the transparency, as you can see in the photo. But the GETA glass system allows for smaller prospective dimension of slender supplementary glass compared to the lipped glass construction, which results in greater transparency. So everything's good and it looks cool. And the purpose of this study is to obtain basic data on mechanical properties of GETA glass system by testing and analytically verifying the integration of flat glass and slender glass stiffener for the practical use of GETA glass system. Okay, for the analysis, elastic analysis was performed, and the test results of the bending test were compared with the analytical value. Okay, this is how the experiment was done. using the Amsler type compression testing. And it was used to conduct a 3 equal length 4 points bending test. And this is how the test was done in our lab. Okay. The thickness of the sealant is 20 millimeters, and the sealant used is silyl terminated polyacrylate sealants. The dimensions of the slender glass stiffeners are 80 millimeters, 3,000 millimeters times 15 millimeters. And the dimension of the glass are 300 times 4,000 times 12 meters. Okay, to prevent the specimen from being damaged at the point of contact with the testing machine, hard rubber of 3 millimeters thickness was placed between the flat glass plate and the force application area, between the flat glass plates and the support points. Here's the overview of the analytical model. For the loading of this analysis, an elastic analysis is performed by setting up a concentrated load at the force points. The force is applied at the points where the distance is divided into 3 equal sections, which is 1,200 millimeters from both supporting points. And this is how the test specimen was operated from the left, which was before, and to like this. Okay. And this is the load-related deformation curves obtained from the bending tests. The vertical axis indicates the applied loads, and the horizontal axis indicates the relative deformation. And the test shows that the value of the stiffness of the flat glass with the stiffeners was 8.7 times higher than what is without stiffeners, which means compensating effect was obtained by bonding the slender glass stiffener. And this is the analysis results. Also, we have compared the analytical values and test values obtained from the bending load experiments, and here is the analysis results. As a result, we could confirm that the difference between the test specimens with flat glass at the spot point location and the initial stiffness of the analytical model was within the range of 10%. And this is the latest completed facade project in Japan, which is near Osaka, and now it's already ready to be used, and at the junior and senior high school library. And thank you very much for listening. It was.